Alright, here we're on the last segment. I got two examples at the bottom of your page where we're applying some of the vocab, and this is missing on your paper because I don't think there's a way to draw a circle symbol. You'll often see it says draw circle P and radii GP and SP, and the measure of angle GPS is 120. This is just a way of explaining the center of the circle. If I said circle K, K would be the center. If I said circle H, H is the center. If I said circle, J, J is the center. So draw circle P. So there's your circle. The center of that circle is point P. So there's P. GPS is a 120-degree angle. So add G and S on there essentially. So this was G and this was S. You'd have GPS. You want this to be an obtuse angle. You want it to be bigger, a little bigger than 90. You want that to look like it's around 120. So this is a hard problem. You could read this problem to yourself, do it on your own. It's going to apply a little bit of trig or a little bit of ratios, special triangle ratios if you want to just go ahead and try it. If you're one of those advanced people, I'd go for it if I were you. I'm going to do it without trig. I'm going to do it with ratios in a moment here. So as you read through the whole thing, you see, it's a good time to pause, like I said, but see the circle's diameter is 16. How long is GP and PS if the circle's diameter is 16? Of course, those are both 8 because radius is half the diameter. This angle's 120 because it was given. And it's asking you to find GS. It's asking you to find that distance across there. So think about this. If that's 120, now we actually have a triangle. Now the circle kind of relates to triangles, which you've done a heck of a lot with those. Think back to the last chapter. If we draw the altitude for the triangle, what happened to my 120-degree angle that was up here a minute ago? It's pretty obvious that got cut in half. If I drew an altitude here, and these are an isosceles triangle originally, originally that was isosceles, I cut it in half. These are both 60 now, the top angles, 60 degrees and 60 degrees. If these are both 60, think about how much that angle is. That's 30, that's 30, these are 90. So you got a 30, 60, 90. I would do this all with 30, 60, 90 ratios. I think it's much easier. Quiz yourself on your 30, 60, 90 ratios, refresh them. I know you used them a lot over spring break, probably, right? And if not, you remember it's a 1 to rad 3 to 2 ratio. And I'm giving you the hypotenuse of each of those. So if I give you this as 8, it's pretty easy to get the altitude. This 8 should be twice as much as this one, so the altitude is 4. And then this little piece here, or this little piece here, you can figure out is bigger than this one. It's rad 3 times as large as that. So that little piece is 4 rad 3. Reread the question. Find GS as this entire thing. Well, it's twice as much as that. It's 8 rad 3. So there's your answer. That's that you have to read it. You got to analyze a couple things, draw an angle, draw some radii, think of interpreting a diameter. Not too hard a problem, and find the length of a chord using ratios. So you could have done this with Pythagorean theorem, maybe. You could have done this with trig. I have no idea what this is approximately. It's whatever 1.7 times 8 is. If you did it with trig, you'd probably come up with something similar to that. You can certainly check it with a calculator. All right, the last one. And I don't know how much I gave you on your drawing. I think on your paper I just gave you 2 circles that intersect kind of like a Venn diagram. So a couple givens on here. Circles are congruent. That's one of the first things, which means each circle has a radius of 6. Now I drew on this little shape here. Think for a minute. You got to think way back to chapter 6 what type of quadrilateral this was. If I go back to the fact that every one of these little segments are an interesting type of segment. And the little red dots, they do represent the center of the circles. So something that, and I'm looking at the screen, it may not be obvious to you. You may not think it's drawn to scale. But each of these circles, they intersect each other in 2 places. And then the circle center, this circle center is actually on the edge of this circle. And vice versa. This circle center is here. This circle center is here. This point is on that other circle. Which means each one of these, hard to see this, each one of these is a radii. This is 6, this is 6, this is 6, this is 6. Which means this is actually a little rhombus. So what I'm asking you to find here, find the length of AB, find the length of this. Basically, if you think of a rhombus, this is the diagonal of a rhombus. And I'll label some of these radii on here. These are each 6. This one's 6, this one's 6, 6, 6. They're all 6 on there. I'm asking you to find that vertical distance from A to B. Again, I would pause it right now and go for it. You should know how to do this thing. It's not easy, but you should know how to do this thing. Good time to pause. It may help you to draw one more radius on there. And the radius I'm referring to is the radius that connects the two circles. The two centers of the circles, I should say. So this is another radius. I'm just spinning this radius around here. I'm going to do it with a pen cap here. Spinning this around. This is 6 here. Well, it's still 6 here. And as you know about rhombuses, this is getting split in half. Each of these are 3. So if this is 3 and this is 6, you can pretty easily find this distance. And once you find this one, you just double it to find the entire thing. How would you do that? You'd probably use Pythagorean theorem. 3 squared, I'm going to call this h, because it's kind of like the height here. 3 squared plus h squared equals 6 squared. Some of you might even realize it's a trig ratio again. This is a 1 to 2 ratio. If this is a 1 to 2 ratio, I think this is a 30, 60, 90 triangle. I think you end up with, and I'm doing an approximate on this one, but this would be half of that one, so this must be 3 rad 3. Which means this entire thing should be 6 rad 3 if you go with ratios again. I was thinking Pythagorean theorem is approximately 5.2. That's this part of it. If I want to find the entire thing, of course, I've got to double that. AB would be 10.4, which I'm going to guess 6 rad 3 is probably approximately 10.4. So there you go. We've not escaped Pythagorean theorem. We haven't escaped special triangles, and we haven't escaped trig. The circles are really a chapter where everything's still integrated in there. Maybe that's the reason we're doing circles ahead of chapter 10. So I'll be back tomorrow. Good luck. There's a homework assignment. It's on Schoology. It's out of the book. Sorry, not out of the book. It's actually a worksheet you'll get from Mr. Snyder, the sub. You're going to need a ruler, and you're going to need a calculator, and you're going to have to explain with some words on here. Concisely and completely. Concisely, you can look that word up if you don't know what that means. That means I don't want to see a book. I want to see clear, simple responses that are direct, but also conclusive. So, have a good day. We'll see you tomorrow.